Chapter 3, Solving Systems of Equations. What does that even mean? So we have a system of equations. That means we have two different equations, and when we solve them, we figure out where those two equations overlap or cross each other. So we're going to go into solving by substitution. When we solve by substitution, we want to get one of the two equations. So this is my system right here for A. We want to get one of the two equations where one variable is completely by itself. So if I look at my second equation right here, I'm going to use the second equation because this y doesn't have a variable in it. So this one's going to be really easy to solve for y because I'm going to subtract the 2x. So this equation right here would be negative 2x plus 10. So that's your first step, is to solve one of the two equations for either one of the two variables. Now you use this equation, which is my second. You use this equation and plug it into this first equation. So we're going to plug it into this y because that's what y is equal to. So we have 3x plus 4y. Now instead of writing y, we write what y is going to be equal to. So I'm going to have 3x. I'm going to first distribute. So this becomes a negative 8x plus 40 equals 12. So this becomes a negative 5x, and I'm going to subtract my 5 over. And when I subtract the 40 over, I get negative 28. And then divide by negative 5 on both sides. X will be equal to 28 over 5. Now what I can do with this, since I know what my x value is, I can go back to this equation up here to figure out what my y value is. Because really you're trying to figure out where these two equations cross each other. So they're both linear, so it's going to be just at one point. So I plug negative 2, and then I plug 28 over 5 plus 10. And I solve that, I get negative 6/5. That was equal to my y value. So my overall answer is whatever x value comes in place of the x, and then my y value. So this is the point where those two lines, if I were to graph them, they actually cross each other. So I want you to try to do B by yourself right now. If not, we will be going over it tomorrow. So that's the first way, is substitution. Some people really like that way. That's not my favorite. Elimination is my favorite. So elimination is kind of the same process. We're going to be thinking of, well, if we were to graph these two lines, where would they cross? Because that would be my solution to the system. Solution to the system are where the two lines, your two graphs, would cross each other. For elimination, I'm actually going to do, well, actually both A and B are kind of the same, so I'll just do A. So for elimination, you always want to try to get one of the coefficients, so either the x or the y, to be the exact same number but opposite. So if I look, this one's already set up for elimination. If it's not, we're going to have to multiply by something, which we'll get into in class. But since this is already a positive 4x and a negative 4x, you can then add these two equations together. So when I add 4x plus negative 4x, those two cancel each other out. When I add 2y plus 3y, that gives me 5y. If I add 9 plus 16, so it's adding each one, 9 plus 16 would give me 25. And then divide by 5, I get y is equal to 5. Now in this case, it doesn't matter which one I plug it back into. I can plug 5 into my first equation, or I can plug 5 into my second equation. I'm going to do my first equation just because the x is positive. So I can have 4x plus 2, and then plug in 5 is equal to 9. So I have 4x plus 10 equal to 9. Subtract the 10. I get negative 1. And then x is equal to negative 1/4. Again, that's not my overall answer. You have to write your answer as an order pair. So my x values are always written first. My y value is always written second. So this would be my answer. I want you to try B by yourself. So what is the solution of the system? So if it's not telling you to use substitution or elimination, you get to choose. I personally, like I already said, I really like elimination. So this is actually a great problem for elimination because if I look at this, my x's and my y's don't actually cancel out yet. But I know if I solve by substitution, I'm going to be dealing with fractions. And I'm not a fan of fractions, but they're just numbers. So what you can do is rewrite the system. So I'm going to put this because I'm going to rewrite these two equations. I'm going to multiply this top equation by -3. So each term gets multiplied by -3, so that means I'm not actually changing the graph at all. If you were multiplying by the exact same number, it's not actually changing the number. So that becomes a -6x minus 21y minus 12. And I'm going to multiply this second equation by a +2. Again, each one, so I have 6x plus 10y is equal to -10. And you might have been able to see now, why would I do that? Why would I do such a thing? Well, when I did that, I was able to get these two x's to be the same number but opposite. So now because of that, I can add those two together. So this becomes 0, this would become a -11 is equal to a -22, -11y, sorry, is equal to a -22. Divided by -11, I get y is equal to 2. And I can plug it back in any equation. I'm going to plug it back into this original equation. It doesn't matter, again, which one you plug it into. So I have 2x plus 7 times 2 equals 4. Of 2x is equal to, this is 14, so if I subtract 14, I get -10. X is equal to -5. So my answer is -5, 2. So that is my answer. Try the next one by yourself, however you wish to. So here again, I can solve by substitution elimination. Because I did the last one by elimination, I'm going to do this one by substitution, just because. I'm going to rewrite this first equation so it says y equals. So this is going to be y equals, I'm going to add over my x, and I solve this in -2. So I'm going to put that in place of this y. So I have 2x minus 2, and then I have x minus 2 in here, is equal to 0. Distribute, remember this is a -2. So I have 2x, and this becomes a -2x, and this becomes a +4 equals 0. These two, if I combine like terms, cancel each other out. So I have 4 equals 0. So if this happens, you have to think to yourself, is this a true statement or false statement? This is a false statement. Wah. Here's a little tear for crying. Wah. So if it's a false statement, that means there's going to be no solution. There's no solution here, or else you might see me do that. No solution. If for some reason you get a true, if it was a true statement, if you got something 2 equals 2, let's say, it'd be infinite solution. Infinite solution. There you have it. 3.2. You have a grand day.